Hey guys, so today we're doing our second example of graphing cosecant and secant when it's been transformed. So this one, remember, first thing I'd like to do is secant of x equals 1 over cosine x. And again, we're just going to start by turning this into the cosine function. So y equals negative, and then we're going to say negative cosine instead of negative secant. This is something that we know how to graph, and then it makes it extremely easy to go from cosine to secant. So I like to graph that first, and then now let's just remember our transformation rules. Let me write them. I'll write them over here. Y equals a, and then cosine of bx minus c plus d. Just quickly, a is the amplitude, says how far up and down it's going to go. B is defined as the period, and it's 2 pi. For cosine, it's 2 pi divided by the absolute value of b. C, that helps us figure out our phase shift, so PS, I'll call it horizontal shift. And that can be defined by C divided by B. And then finally this D is our vertical shift, so VS. So now let's try to apply all this stuff to this function right here and graph it. We've got y equals negative cosine of x plus pi minus plus 2. So we've got negative here. That's an x-axis reflection. So first, x-axis reflection. That tells me that instead of starting at the normal, we usually start at 1 for cosine. Now we'd be starting at negative 1. That's all that's going to do. And then, trying to erase that point. Okay. And then we have this up to thing that we've got to do next before we can get into some other stuff. So I'm going to say we want up to. And then we can do, okay, what's our period? Our period is still going to be, we defined it as 2 pi divided by b. Well, b is just 1, so it just equals 2 pi. Nothing changed there. Then finally, our phase shift, we said, well, that's c over b, and c is just going to be pi here, because the formula calls for bx minus c, so minus pi. So c is just pi. Pi over 1, so it's just pi. So then we went to the right, pi units. And after we do all that, we'll be able to graph our function. So I'm going to start with my normal cosine function here. I'll just draw a quick sketch before we put it on the real graph. We start here, we go down, we go up, we go down, we go up. And then, okay, it says, well, first thing we did, x-axis reflection. That flips everything over. Let's account for that. We're going to be starting down at negative 1, so we're going to go up and then down, going to go up and then down. Alright, and then we went up 2. Okay, well that's going to bring, instead of going, we're going to be down at negative 1, then we went up 2, so now we're at positive 1 starting. And then we went from our original, let me rewrite this, we were going from negative 1 to 1, then we just went up 2, so now we're going to be going from 1 to 3. So this point's 1, this point's 3, and we've still got where we're starting at the bottom now, and going up, and then going up and down. And then right pi units, so then we're just going to move this whole graph to the right by pi. Now I'm ready to draw it here. I know in general what I'm expecting. I've got a minimum of 1, maximum of 3, and my starting point, I went right pi, so my starting point is going to be at pi. And I know that I'm starting at the bottom because there is a reflection. Alright, and now I can start drawing the finer points. Still counting by pi over 2 because there's no period change, so 2 pi, I'll go back a little bit, pi over 2, we got 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so we're starting at the bottom and we know we're going up, so we're going to be, well, let's draw this midline. The midline's always halfway between the maximum and the minimum. So the midline in this case is 2. That just helps us draw our points. So at 3 pi over 2, we're going to be right there. And then we're going to be up at 2 pi, we'll be up at 3. Then we'll be going down, back. And then here, at pi over 2, we're going to be at the midline. It's not a very good line. Pi over 2 midline, and then we'll be up at 3 at 0, and then we'll start going down, down, back up, and you get the point. So that's their cosine function. And if you remember, I'll get the blue to draw the secant function. If you remember, every time that the cosine function touched the origin, we were drawing asymptotes. So now, not the origin, every time it touched the x-axis. So now instead of the x-axis, it's every time it touches the center line. So here, that's one, and that's one, and this is one, and that's one. Alright, so now we just have to draw our asymptotes there. Every time it touches the center line. Here we go. Drawing them in. And there would be one here. If you remember, just like cosecant function, secant you draw a point where it touches, and then you draw like a parabola pretty much going towards the asymptotes on both sides, and then we do the same thing here at each one. Parabola. And that's going to be it. That's going to be our secant function. So again, it's a lot easier if we just start out by drawing the cosine function and then just having the parabolas come off of the tops and the bottoms. I hope this was able to help. I hope that made sense. Sorry, this graph looks pretty confusing, but I think you get the general gist. Let me know if you have any questions. Have a good one.